record. All right, so we left off with, we had finished min, right? I believe we did. Yeah, so we said if it's empty, we return null, because I think we did this part first and we realized when we tested it when it was empty, it threw an error. So we had to come back in and add the check for is empty. So max, and let me just review real fast. We have a I almost said singly linked list. We have a binary search tree. And the rules are, if we have a root, we always start at the root. So if it's empty, the first number we put in our tree is going to be the first number, it's going to be the root. So if this is 42, we automatically have a node that has the data value and also a left and a right. Okay. The left is where we put numbers that are less than the current node. And the right is where we put numbers that are greater than the current node. So if we come along and we want to put in 55. Oh boy, 55, there we go. We check the data of the node and see if it's the number we're trying to insert is greater or less. So is 55 greater than 42? Yes. So we go to the right. If the right property of the node is null, then we're done. We just insert 55 here. Right? And then as soon as we create a node, it automatically has the left and right properties set to null. Okay. What if I want to insert 13? I ask, is 13 greater than 42? No, it's not. So I move to the left. If the left node is null, then we insert. So this becomes 13. All right. Now, what if we want to insert 37? So where does the 37 go? What's right? So 37 is, yes, I'm losing it. Yeah, so 37 is less than 42. So we go this way. So the 37 moves down here. Because now the reason we move down is because 42 doesn't have an empty left property, right? So we move down to the 37. So we're basically asking two questions. We say, is 37 greater than or less than 42? It's less. Okay, so if it's less, we check, is the left node empty? If it is, we would insert the 37 here. If it's not, we iterate, right? We're going to take the next step of our loop and we're going to compare 37 to 13. Is 37 greater than 13? Yes, it is. So we go to the right. But we check. If this is empty, then we're done. If it's not, then we got to keep hopping to the next node, right? So 13's right node is empty. So we, and I shouldn't say this, node is empty. The pointer's empty. So we put 37 here. Okay. I think I feel like I'm beating a dead horse at this point. Everybody understands conceptually what's going on, right? Okay. So if we want to find, so let me just insert a couple more. So 55, let's insert 87. And let's 55. So 50, where would 54 go? 54 would go here. And let's do 93. So if 93, we know that 93 is our max, right? That's what we're going to be looking for in our max function. So when we looked for the min, we said current dot left, and we just kept going until current dot left didn't have a left, right? Until we hit null. Once we hit null, we were done. So how would we find? That's the min. How do we find the max? Where is the max? There it is. Yeah, we go all the way to the right, right? So, but what do we need to do? What do we need to do first?
Check if it's null.
Yeah, check if it's empty, right? So, and I can't remember how we did it. How do we do it? If this, okay, so if this not empty, if this dot is empty, it wants us to return the data, right? So there's nothing here, right? This is the largest integer from the tree. There's no integer, so we just return null. Okay. And then what do we do if, how do we traverse the tree? Let me get this out of here. So basically the same thing, right? We're just going to do the opposite. So while current, what? What are we checking? Yeah, if current dot right. So while current dot right, while it's not null, right? While there is not a null value, we're going to keep iterating. And how do we iterate?
The current equals current dot right.
Right.
Yeah, it's definitely Smith.
Current equals current dot right. Yep. So when this while loop finishes, we're there, right? We're done. So current will be the biggest node, or I'm sorry, the bottom of the tree, right? Basically the end of the right side of the tree. So then we just return current dot data. Right? So it's basically just a mirror image of the min, right? We did the same thing. I could have just copied and pasted this and just replaced left with right. Okay, any questions? Okay, let's test it. So, oh yeah, so we had the root node. So if I move this down, save it, the minimum was 3, right? So this should yield 3. So, oops. Node index.js, we get 3. So what should tree.max be?
50.
50, right? Let's see what we get. Cool. It works. All right. Stephanie, are you here? Please be here.
Yep.
Okay. Let's do min recursive.
Yeah.
It's fun, right?
I love recursion.
Oh God, I love it. I love it so much. All right. What is our base case? When are we done? Right? When we're looping here, when were we done? What was current's value that made us be finished?
To the left equals null.
Right. So when it was null, we're done, right? Well, there were two cases, right? We did is empty, but what was current in this case? If it's empty and we want to stop, what is current? Without checking left or right. The smallest, but I'm thinking about when it's empty. When it's empty, what is current?
It's null.
Null, right. So if current is null, then we want to exit, right? We want to have that case where there's nothing in the tree, right? So we're going to say if current equals null, we're done, right? We're just going to say return null.
Is that the same as if this is empty? Return null?
Yes. Yeah.
Okay.
We could have done that. We could have in the regular loop method, we could have just said if current equals null, return null. Or we could have just said if, well, basically we could have said if this dot root equals null, return null. Okay, so what's the other case where we know we're finished in terms of the minimum?
The left equals null, right? Or didn't
Yeah.
we just say that?
So if current dot left equals null, what do we do?
Return current dot data.
Right. Return current dot data. Okay. So those are the two base cases. Those are the two cases where we want our recursion to stop. Okay. So now, how do we recurse? What is the recursion step?
Return the function.
Yep. So we return this dot min recursive. And then how do we iterate? Right. So we pass in, do we just pass in left? Oh, okay, I see what you're saying. Okay, so we pass in current dot left. Right? Does that make sense?
Just a quick question. Do we need to have this? I'm just wondering.
You mean this? Where this?
This dot name recursive. I'm just wondering.
I believe so.
Okay.
I believe so because now you're making me wonder.
Because if we're putting in the next one, then like,
Yeah, because if
maybe we don't need it. Maybe we do. I don't know.
Let's try without it. So let's test it first this way. So let's do min tree dot min recursive should yield another 3, right? Cool. Now let's try it without this. I want to say it's going to throw an error, but my JavaScript is rusty. Where'd it go? There it is. Yep, throws an error. Okay, let's see what the error is. Min recursive is not defined. Yeah, so we need to specify when we're calling a function within, well, I guess a method at this point. Calling a method within a class, we have to say that it's the method that belongs to this class.
Oh, because you're saying it's within a class. It's not just a function.
Right. Yeah, the this points to the class. The this is our binary search tree. So to access anything within the class, we have to say this dot, whatever we're accessing, whether it's a method or a property. Cool. Now let's do max recursive. Okay, so you guys tell me what to do. Check if it's null. Okay, so we're going to say if what? Current
Equal,
equal
null,
null. Okay, cool. And what do we do if it's null?
return,
Yeah, return null. So that's the case where it's an empty tree. Now we got to handle the case where it's not empty. So what do we check?
Right.
Okay, so if current dot right equals
null,
null, we return what we want, right? So we return current dot right. I'm sorry, current dot right. No, I'm losing it. Current dot data. Sorry, current dot data. Cool. So those are the two base cases. Now we recurse. And recursion is just calling a function within a function. So we're going to say this dot max recursive. And then what do we pass in? Oh, I'm going to mute you. So max recursive, what do we call? Or what do we pass in?
The current dot, right?
Current dot right. Cool. Let's give it a try. So, oh, I forgot to test it. So we did min, we did max. Let's do max recursive. So we should see now 3, 3, 50, 50. Cool. And it works. Any questions? Okay, so I'm going to try something. I tried to do this before, and I think now I know why it wasn't working. So let's see if I can get this to work. Okay, so if I open this in a separate window, and just to try to visualize what's going on with the recursive, I'm going to put a breakpoint. Where am I going to put the breakpoint? I think I put it here. And then if I run this in debug mode, we can start to see what happens for when we recurse. So actually, let me stop. Because I don't want all of them to run. I want to just run the recursion. So let me comment this out. Comment this out. Do I want to do the man? Yeah. Good. Okay. Let me save that and run it. Okay. So when I run it in debug mode, basically the breakpoint tells the computer to stop operation where I put the breakpoint. So I put it right here. I don't think it matters if I put it down one. So what happens when we call recursive functions? So if I step over this, so can I step back? No, let me start and stop. Okay, so over here it shows you what all of the values are. So current is at 50. We're looking for the minimum, right? So we're checking to see if current equals null. And right now, is current null? If it's a node, then it's not null, right? So what's going to happen when it hits this point, when it hits this if statement? It goes on to the next one, right? Then it checks to see if current dot left is null. It's not, right? Current dot left is whatever it is. I think we put 4. Okay, so if I step again, then it goes to the return statement because these if conditions aren't met, so it's going to return a call to this function. So notice the call stack. When I step again, it pops that function that it returns, that recursive function, onto the stack, and then it goes on to the next one. Okay, so notice now there's 2 function calls on the stack. When I step through again, current is not null, so it's going to go on to the next one. Current dot left is not null either, so it's going to go on to the next one. So now it's going to recurse again. And so returning this dot min recursive is going to pop another min recursive function call onto the stack. So notice now there's 3. We're going to check current again. It's not null, so it's going to skip the base cases. Left is not null, so it's going to skip it, and then it's going to recurse again. So recursion is just we keep adding items onto the stack until we get to the point where one of these if statements is true. Then they start popping off, and the final return will be the value we're looking for. So we're still at, so we're still not there. Now we're at left equals null, right? So right now left is null. So now the if statement's going to fire, so it's going to return current.data. Oops. And then if I keep clicking the button, you'll notice that the functions on the stack start popping off. And once they've all popped off the stack, we get our 3. Okay. Does that help a little? Sort of make sense of what's going on with recursion? Okay. All right, any questions? All right, sweet. So let me